Hello guys, welcome to Physics Vedika. So today we'll be learning about transistor. Watch the complete video to understand transistor as a very simple concept. What is a transistor, right? There are many electronic devices consist of transistor. Why? Because the transistor has a wide variety of applications. It is useful to amplify the signal and also it is used as a switch, right? Transistor as an amplifier and transistor as a switch we'll be learning in detail later. Okay, basically there are two types of transistors. Let's look into them. NPN transistor as well as PNP transistor. NPN and PNP. What is NPN transistor? NPN. NPN. Right? What is that? You are keeping a P-type material between two N-type materials. Right? You are keeping a P-type material between two N-type materials. And that is how you will get an NPN transistor. Or we can say that by sandwiching a p-type material between two n-type semiconductors, we will get an NPN transistor, right? Sandwiching a p-type semiconductor between two n-type semiconductors, right? We will get the NPN transistor. What is the PNP? PNP is also very simple. When we sandwich an N-type material between two P-type materials, we will get PNP transistor. Yes or no? Right? And also we can say that in any transistor we have two PN junctions, right? You can see there is one PN junction here and another PN junction is formed, right? Even in PNP transistor also we can see there is one PN junction here and another PN junction here. There are three terminals for the transistor. Each transistor in NPN also we have three terminals. In PNP also we have three terminals. And you can see there are names for these terminals. One is known as emitter, the other one is known as base, and the other one is known as collector. What is the difference between these three things? Emitter, base, collector, right? Emitter means basically which emits the process, means which will start the process. Transistor has to work, it has some function, right? So that work will be started, that functioning will be started from the emitter. That's why we call it as emitter. Okay. And also what is the differences between emitter, base and collector? Emitter, base, collector, you can see emitter, you can observe that it is from the diagram you can observe that there are more number of charge carriers here, right? What are these charge carriers? How we are getting more number of charge carriers? Because we are doping it more, right? It is heavily doped. So when you heavily dope it, then you will get more number of charge carriers. What is this transistor? It is NPN transistor, right? As it is NPN transistor, you have, it's a N-type material. N-type materials means majority charge carriers are electrons. So that's why we have many electrons here in this region, right? So same thing, even in the PNP transistor also, emitter is heavily doped. Everywhere it is heavily doped only. Why? Because it has to start the process, right? So it is a PNP. P means what? P means positive, or we can say holes. Okay, right? So there are more number of holes are the majority charge carriers here. So emitter is basically heavily doped thing here, right? Then comes to base. Base is lightly doped, okay, or very lightly doped. And when it comes to collector, collector is moderately doped, not very high, not very low, moderately doped. That's the difference between emitter, base and collector in terms of doping. Doping means what? Adding impurities. Adding impurities. So here we are adding more impurities. So we have more electrons here because it's N type. And here it's a P type. So we have more number of holes here. Right? In both the cases, doping is more for emitter. Then comes to base and collector. Base is lightly doped. You can see there are very less number of charge carriers here, right? And here also you can see very less. Collector is what? Moderate. Moderate means not very high, not very low, in between, the medium, right? And also in terms of size, when I talk about the size, I can say that generally transistor, if I draw, I will draw like this. I will take like the emitter, this is the base, this is the collector. You can see the collector is very large size. Collector is in the very large size, and base is very thin. Base is very thin. There is a very usefulness. Why we are doing like this? Not for a time pass. There is a usefulness. That's why we are making the base as thin. Okay, guys. And emitter is like moderate size, medium size. Okay, medium size, and it's large size. This is a difference in terms of size. Okay, now, this is a difference in terms of size basically. Okay, then comes to, so as I said, emitter is very heavily doped and it's medium size. Base is lightly doped and it's very small, it's very thin, very useful. And collector is moderately doped and it is very large. It is very large in the size. Let us look into the symbol of transistor. As you can see, there is an NPN transistor, right? So there is an arrow from base to the emitter. What is it indicates? It indicates the direction of current from base to the emitter. The electrons will move from emitter to the base, so the current will flow from base to the emitter. And similarly, in PNP transistor, you can see the holes are the majority carriers and they will be moving from emitter to base. So the arrow represents direction of current from emitter to base. And you can see why the current flow in this direction clearly in working of transistor. How transistor is working? Let's try to understand this, guys. It's a very important thing. Let's try to understand this, how a transistor works. A very simple logic. Okay, first you have to keep 2 points in the mind. What are these 2 points? One is emitter base junction is in forward bias. FB stands for not Facebook, it is forward bias. So emitter base is always forward bias. Then comes to collector base junction. Collector base junction is reverse biased. What is this emitter base junction? You have a emitter, this is a transistor, right? In this transistor, emitter, base, collector. So emitter base junction. Emitter base junction means what? This region. This is the emitter base junction, right? Then base collector junction. Base collector junction means base and collector, right? So this is one junction, this is another junction. Two junctions are formed. Emitter base junction, this one should be in forward bias. Then this base collector junction should be in reverse bias. Understand? FB stands for forward bias. RB stands for reverse. Why? Because this is the basic condition for working of a transistor. If a transistor has to get activated, whether it is an NPN transistor or PNP transistor, no matter, if your transistor has to activate, then your emitter base junction should be forward bias and collector base junction should be reverse bias. Why? Why this is the thing? You'll learn it. You will learn it. I will show you. But first check whether your NPN transistor and PNP transistor both are following this or not. Let us see this. Look at this. NPN transistor. NPN. The first one is emitter, the second one is base, and third one is collector. Now let's try to understand whether emitter base junction is in forward bias or not. Yes, it is forward bias. Why? Because you can see forward bias means what? N type should be connected to negative terminal and P type should be connected to positive terminal. Right? That is the condition of forward bias. Yes or no? So you can see this is the P region, this is connected to positive terminal, and this is the N region which is connected to the negative terminal. So you can say that emitter base junction is in forward bias. Okay, then collector base junction is in reverse bias or not. Let's check this junction. Reverse bias means what? N type is connected to positive terminal and P type is connected to negative terminal. Now you can say that N type is at the higher potential, P type is at the lower potential. Now let's check. Yes, N type is connected to positive and P type is connected to negative. Right? So comparatively, you don't say that it's connected here. Okay? Think at the voltage difference, okay, potential difference compared to the P type. N type is at the higher potential that you made, that is the reverse bias you made. Okay, so now this is a good thing for a working of a transistor. Then the transistor will be activated. Yes, of course it is activated. We will see what will happen if it gets activated. Okay, now we are going to learn about NPN transistor, mainly trying to learn the working of transistor with the help of NPN transistor. Okay, let us see. So we are considering one NPN transistor to understand how a transistor is working. Okay, first condition is what? Emitter base junction should be forward bias, collector base junction should be reverse bias. We have made that already. When you make emitter base junction in forward bias, what will happen? It is an NPN transistor, right? NPN. Forward bias means what? Forward bias means basically, suppose if you have N type and P type material like this, N should be connected to N and P should be connected to P. Then what will happen? We know that during the forward bias condition, you are creating an electric field in this direction, right? This is the external electric field with the help of the battery you are creating. So when you create the external electric field, and which is greater than the your potential barrier, the electric field due to the potential barrier, so because of that the electrons will start drifting in this direction, right? So these electrons will be start drifting in this direction. That is the thing about forward bias, right? Or you can say the holes will start moving in this direction. So same thing happens here also. You have made the emitter base junction forward bias. So you can see in this diagram, you have made the emitter base junction forward bias. So what will happen to electrons gets attracted towards the base junction, right? Because here you can see this is the emitter, this is the base. these electrons, which are majority charge carriers, will attracted towards the base. So they will start moving towards the base because you have created electric field in this direction. How you created this external electric field? By connecting the battery like this, by connecting the battery here. Now these electrons which are moved into the base region, we know that base is basically very thin, it's very thin, okay, and also it is very lightly doped, so because of that, few electrons will be combining with the holes, and majority of the electrons will start entering into the collector region. Because the base is thin, so they just enter into the collector region. So this is the basic point you have to keep in mind. As the base is thin, they enter into collector region, and this process is also gets help because of this reverse bias condition of the collector base junction, right? So what you made here, you made the collector base junction in the reverse bias condition. So when you make the collector base junction at the reverse bias condition, it means what kind of electric field you have developed here? You have developed electric field again in this direction by connecting this battery, right? See, you have the base and you have the collector. What you did here, the base is very thin first of all, right? And you can see from collector to the base you have created the electric field. Why? Because you have connected the positive terminal here and the negative terminal here, or you have made this reverse bias. Reverse bias means what? This is the N type material is connected to the positive terminal of the battery, and P type material is connected to the negative terminal of the battery. So this creates an electric field in this direction. Then again these electrons which are there in the base, they will move towards the collector. So majority of the electrons are moving into the collector region, right? And only few of the electrons are moving from the base and they are going back to this battery here. They are entering into the battery, which will give us the IB, that is the base current, and which is very very small. Why? Because only few electrons are going this way. When electrons are going in this way, you will see there is a current in this way, right? So that is what happens here. So the base current is very small because only few electrons from the base are going through the battery and enter into the emitter. Is that okay? Right? So that is what happens here. And what do you say about the collector current? Collector current is very high. Why? Because majority of the electrons are moving in this way, and that constitutes of collector current, which is very high compared to the base current. Collector current is very high. And the electrons which are going through the battery VEE and back to the emitter, okay, that will give us the emitter current IE. Basically, so this is the emitter current IE we are getting because of these electrons which are coming from the base as well as the collector, right? So you see here, so the electrons which are coming here in this way from the base as well as from the collector, and they will enter into the VEE and they will move back into the emitter. So this motion of electrons, this is in this way, so the emitter current will be in this way, IE, right? This is the emitter current, or you can say the IE current, which is dividing into IB as well as IC, right? So the IE which is entering this way is dividing into IB and IC. Yes or no, right? We can say that IE equals to the emitter current, which is the emitting one, which is the starting one, is giving the collector current as well as the base current. From where we are getting this collector current as well as the base current? From the emitter current. Understand, right? So that is the idea about the working of the transistor. Okay, let's summarize everything. So basically the two key points you have to keep in mind for a transistor, working of a transistor. One is the base is thin, and the second one is emitter base junction is forward bias and base collector junction is reverse biased. It's an NPN transistor, so majority charge carriers are electrons, right? So the electrons which are starting from the emitter, they enter into the base, but as the base is thin, they continue to move into collector. And also this is getting advantage because the base collector junction is reverse biased. So when you make the base collector junction reverse bias, you will get an electric field in this direction. This is the external electric field. So because of this electric field, the electrons will get attracted in this direction because the electrons move in the opposite direction of electric field. And because of the base is thin, majority of electrons will move into the collector, which will increase the collector current. And the collector current is very high compared to the base current. And the electrons will enter from the base to the emitter through the battery VEE, and also the electrons from the collector enter into the emitter through the battery VCC, and this will give the current IB in this direction and the motion of electrons in this direction, which gives the current IC in this direction, and these together will enter in this direction, which gives the current IE in the opposite direction. Means this is a motion of electrons I am drawing. Overall, we can say that with the help of the current direction also, you can see easily the IE which is entering gives you IB as well as IC. So we can write IE equals to IB plus IC, and the IB value is very small, or we can say the IB is basically 5%, or you can say just 1% to 5% of IE. It means mostly the 95% of emitter current enters into collector region. Okay, so this is the thing about working of a transistor. Hope it's clear, right? So you can see the remaining concepts about amplification and also transistor as a switch in my next lectures, right? If you find it helpful, please like, share, and also you can comment your doubts if you have any doubts, and also subscribe to my channel. Understand, right? Tata, bye bye.